Hi, today I'm going to talk about the optical devices and memory. So let's start. Oh, First, I will talk about the optical devices. Like this is the two type of OLED. So left side is the A active matrix OLED, and this is the passive matrix OLED. So first, we can call it AM OLED, and this is the PM OLED. So first, we will talk about the passive matrix OLED. The passive matrix OLED circuit is very simple. So it connected everything by whole pixels, and then if we put some signal to the lateral side and vertical side, we can control the one cell, one diode, or more blocks of diode. But actually it is not so specific, and because the quality of display is dependent on the circuit. So this circuit, if the circuit is not specified, the quality of display is not very good. So it works poor than active matrix OLED. So but it can make very simple circuit. It can be made by simple circuits. So the many people use this OLED too, but this OLED uses a lot of power, so it is not so good. However, the active matrix OLED is more specific than PM OLED, and because it can control the pixel by pixel. So this is the one pixel operation. So the two transistor and one capacitor works for one pixel. So it is very specified. So if we put some signal to the row selection and data, the transition works turn on or turn off, and the capacitor will be charged. So if the capacitor be charged, is charged, it can save the data. So yes, it works like that. And then this active matrix, the advantage of the active matrix is the power reduction. It uses less power than LCD. LCD use the backlight to make some light. However, it doesn't use any backlight, so it uses less power than LCD. And also this, we can control the every pixels by signal. So we can make the specific colors, and for example, we can make a more deep black color than LCD or another operation. So AM OLED, we use a lot of AM OLED nowadays. And then let's talk about the laser. Laser, and before we talk about the laser concept, we should explain the concept of population inversion. Population inversion means the carriers are located in higher energy level a lot. Actually, carriers don't have a lot of energy in natural. So every material and every carriers wants to locate it in the lower energy level, because it is very comfortable it's comfortable for them. However, if we put some energy, external energy to the carriers, we can make a population inversion situation. So we can make carriers to the we can make carriers located in higher energy level, and then we can use this concept to make a laser. Actually, laser. If when we make the laser, we should use the emission. Actually, the carriers have each lifetimes. So after the lifetimes go on, the carrier lose its energy and then it fall down to the lower energy level. However, the stimulate emission, the situation, and we can use the population inversion concept to this stimulated emission. If the population inversion happens, this higher carrier moves a little bit higher than before, and then it's fall down to the valence band more effectively. So after before another stimulated emission, this population inversion happen. If the population inversion happens, the more carriers can fall down to the valence band effectively. So we should use this concept. And then if the stimulate inversion happened, we can control each energy and each light. So if we gathered the all lights, we can make a coherent light wave. So it has a higher intensity. So it means the laser. So we can make an effective laser to use the population inversion concept. And then we can talk about the laser diode. If the population inversion happens, the diode will be degenerate. Actually, if the degenerate silicon, it has the Fermi level is located in outside of the valence band and conduction band. So the characteristic of the is look like this. Energy band gap is looks like this, and then the optical power and current curve will be looks like this. And then let's talk about the CCD. CCD is the device of memory. And then I will explain how the CCD works. First, if we put some voltage to the left side gate, the electron will gather to the left side, and then if we put some voltage to the middle, the energy at the electron and carriers will move to the middle side. So the carrier moves to the other side, and then if we turn off the left side gate, the carrier will fix on the middle side only, not left side. And then lastly, if we put some voltage to the right side gate, the electron will move to the right side. So we can, if we control the gate bias, the electron carrier will move to the other side, and we can save the data to this device. And this is the CMOS image sensor. CMOS image sensor works by 4 transistor and 1 capacitor. So if we some signal, if we put some signal to the photodiode, the transistor will be turned on and turned off, and the capacitor will be charged, and then it saves some data. So yes, this CMOS image sensor works very effectively, so we use this sensor a lot. And then I will talk about the difference of SRAM and DRAM. SRAM uses a 6 transistor in one cell, so it works very fast than DRAM, faster than DRAM. And then the 4 transistor, the middle side 4 transistor means the latch. So if we put some power, the SRAM will not lose its data. However, if the power disappeared, the data will also disappear too. So it is the negative point of the SRAM. And DRAM has only used 1 transistor in a cell, so it works lower and yes than SRAM. However, also it saves the data by capacitor. So if each capacitor lose its charge naturally, so we should refresh the DRAM regularly. So if we ask to the DRAM, do you have some data? And then if DRAM say yes, we should refresh its data. So it is a little bit hard, but this is very useful to save the data. And then lastly, let's talk about the flash memory. Flash memory looks like this, and then the IV curve looks like this too. This part has a 4 section of the IV curve. So this means the multi-level cell MLC, and this is the type of the saved data. However, nowadays we use QLC, like quadruple level cells. So this flash memory technology develops more and more nowadays. So this is the very important technology to this generation. So today I talk about the optical devices and memory. So thank you for watching my video. Bye.